Hi, everyone. My name is Cailin Nelson, and I'm the Executive Vice President for Cloud at MongoDB. Welcome to the MongoDB podcast. So we went on this journey where we were getting more and more intimate with helping customers run MongoDB themselves. And then we said, okay, let's take the final step and let's actually run MongoDB for our customers. At that point, we were in a really great position. MongoDB had spent 4 years building these tools to run MongoDB, and all we had to do was take those tools and use them ourselves, and also layer in all of the hardware management. What customers had been taking care of themselves was, of course, there is a computer and it is plugged in and it has an appropriate operating system and enough CPU. So we did have to take on that last step of actually managing all of the hardware or virtual hardware.
Welcome to the show. My name is Michael Lin and I'm a developer advocate at MongoDB. I'm excited to welcome you to this series of episodes created to celebrate the 5-year anniversary of the launch of MongoDB Atlas, our database as a service platform. In this series, my co-hosts and I will talk with some of the people responsible for building and launching the platform that helped transform MongoDB as a company. Beginning with episode 1, the on-ramp to Atlas, we chatted with Sahir Azam, Chief Product Officer, and Andrew Davidson, Vice President of Product, about the strategic shift from a software company to a software as a service business. In this, episode 2, Zero to Database as a Service, we're chatting with Cailin Nelson, Executive Vice President of Cloud, and Cory Mintz, Vice President of Engineering, about Atlas as a product and how it was built and launched. Coming up in episode 3, we'll go mobile, talking with Alexander Stigsen, founder of the Realm mobile database, which has become a part of the platform. And finally, in episode 4, we'll wrap the series up with a panel discussion and review some of our valued customer comments about the platform. Thanks so much for tuning in. Please take a moment to subscribe for more episodes, and if you enjoy what you hear, please don't forget to provide a comment and a rating. This will help us to continue to improve. Stay tuned. Welcome to the show, everyone. Let's get right into it. Today, we're diving a bit deeper into the Road to MongoDB Atlas, our mini-series celebrating the 5th anniversary of the launch of MongoDB Atlas, our database as a service platform. I'm joined once again today by my co-host, Nic Raboy. Nic, how are you?
I'm doing great, Mike. This is going to be a great episode.
Yeah, fantastic. Today, we're speaking with Cailin Nelson, Executive Vice President of Cloud Engineering at MongoDB. Cailin, welcome to the show.
Thank you. Great to be here.
And we're also joined by Cory Mintz, who is the Vice President of Engineering at MongoDB. Cory, welcome to the show.
Thank you. It's great to be here also.
And to help guide us through this second episode of the Road to MongoDB Atlas, once again, we're joined by Andrew Davidson. How are you, Andrew?
Good to be back, Mike.
Fantastic. So I do want to take a moment to introduce the folks in a little bit more detail. Cailin, would you let folks know a little bit more about yourself and what you do at MongoDB?
Yes, I have been at MongoDB since 2013. So I joined MongoDB at the very start of our cloud journey. We were just stepping our toes into cloud services, and I think we'll talk a bit more about that in a little bit. Prior to MongoDB, I had worked at a variety of software companies. All of them were consumer services. So MongoDB was my first adventure in more enterprise-driven services, which was a fun and challenging transition.
And Cory, tell us a little bit about yourself.
Sure. I've been at MongoDB for 8 years, just past the 8-year mark. All of that has been on the cloud team. 8 years ago on the cloud team, it was just the cloud team. There weren't any teams under that. It was a small team. As Cailin said, we're just dipping our toes into cloud services.
Yeah, I'm excited to learn a little bit more behind the scenes how this came together. And Andrew, welcome back to the show. Let folks know who you are.
Sure, yeah, I'm VP of Cloud Products. I focus on product management, and it's been a great partnership with Cory and Cailin over the years. We've had a lot of fun.
So you focus on the product end, whereas Cory and Cailin focus on the engineering aspects, right?
That's exactly right.
MongoDB was an organization focused on an open source project. MongoDB has always been available as a download. You can install it on your laptop and you can run it in a data center. You can run it in the cloud on your own. I'm curious about how we transformed and began the transformation process of building a SaaS offering. And I guess I'll ask you, Cailin, talk about your experience building a SaaS offering. Is this something that you've done before? Tell us a little bit about that.
Yeah, before MongoDB, I worked on a music upload and sharing service, and Cory worked on a photo upload and sharing service. So we both had been, working in the SaaS space before we came to MongoDB. I think the transition into Atlas at MongoDB is a cool story though, because we went on this very gradual, learning path as an engineering organization. So before we built Atlas, which is a hosted MongoDB as a service product where we own everything for the customer, before we did that, we built tools to help MongoDB customers run MongoDB themselves. Let's say you wanted to run MongoDB, but you had your own data center, all of your services were in your data center, and you liked being in your data center, but you needed some help managing MongoDB. That's where we started. So the first thing that we did was we built monitoring as a service. So we would monitor those MongoDB processes running in somebody's data center and give them a cloud interface to look at the metrics for their MongoDBs. And we had an alert service, so you could alert if your MongoDB process had gone down, etc. Then we layered backup on top of that, so you could back up the data from your data center to our cloud service. And finally, we added the magic of actually helping customers running MongoDB themselves with the process management. So we gave them a magic web interface where they could go to our web interface and change the version of their MongoDB, and that would actually upgrade the MongoDB process running in their data center. So we went on this journey where we were getting more and more intimate with helping customers run MongoDB themselves. And then we said, okay, let's take the final step and let's actually run MongoDB for our customers. At that point, we were in a really great position. MongoDB had spent 4 years building these tools to run MongoDB, and all we had to do was take those tools and use them ourselves, and also layer in all of the hardware management. What customers had been taking care of themselves was, of course, there is a computer and it is plugged in and it has an appropriate operating system and enough CPU. So we did have to take on that last step of actually managing all of the hardware or virtual hardware. But we went on this really great path where it just seemed very obvious. Okay, we built all these tools, now let's just run them ourselves. And that's how Atlas came to be.
So in regards to these tools, you said that the whole thought process was because people were running MongoDB on their own data centers and we were building services for them. Were these services, did they exist on those same data centers as well, or did those exist on our own data centers and they access them remotely?
Yeah, so it was like we built a cloud-hosted brain that helped people run MongoDB themselves. We still have that product. It is now called Cloud Manager. And actually, if you are really invested in running everything yourself, you can also get a hosted version of the brain, which is called Ops Manager, and run that in your data center as well.
So prior to working on Atlas, I was actually working on that Ops Manager product. And I think that also helped give some good insight at the beginning, because we got to work with some of those larger MongoDB enterprise customers that were not running in the cloud and they were still running in their data centers. So we got to see how they architected their large MongoDB clusters, how they ran replica sets, the scaling problems that they ran into. And that way, when we had that knowledge going into Atlas to see what we could try to avoid.
I love that. And the focus, it seems like the focus at MongoDB has always been on, improving the developer experience, making things easier to use MongoDB, making it easier to develop software that leverages MongoDB as the back end. How long did it take to go from the Ops Manager, or I think we used to call it MMS, is that correct?
Yes, the MongoDB Management Service.
Right. How long did it take to go from some of those assets to maybe version 1.0 of MongoDB Atlas?
It was a pretty short timeline. MongoDB 3.2 came out in December of 2015. And there were some key features in MongoDB 3.2 that kind of, I think, brought us to the point where to say we were ready to build a MongoDB as a service. Let's see, a couple of those were WiredTiger, right? WiredTiger became the default storage engine in MongoDB 3.2. So that gave us kind of more scalability, more comfort at kind of stability at a higher scale. Another key one that people forget sometimes is CSRS, config servers as replica sets. Before that, managing sharded clusters was pretty difficult. The sharded cluster replication mechanism for the config servers was a custom replication. It wasn't really MongoDB replication. And the way that was set up, it actually made it very hard to perform maintenance on those config servers without there being downtime. So those two features plus some other features in 3.2 kind of got us to the point where we were comfortable that we could, run a good MongoDB as a service without any type of downtime. So that was in December. I think Cailin approached me at some point around there. She might remember this timeline better than me and said that, Elliot, who is the co-founder and CEO of MongoDB at the time, and I had been talking about MongoDB as a service. We'd like to build one and launch it at MongoDB World, which is 7 months from that point. We were having that conversation. Would you like to work on it? Cailin, I don't know if there's anything interesting that happened before December that you could fill in. I think that's when it became real for me, because that's the first time I was asked, do you want to be part of this?
Yeah, no, I think the timeline, maybe it had gone back about a month before that for me, but it was very quick. We made a, very quick and I guess committed decision to doing this and launching it 7 months later. And then we just did everything we could to put the pieces in place and make it happen. And it was very fast.
That seems like a really rapid cycle of development. So what was happening on the product side of this, Andrew, as this was coming together from an engineering standpoint?
Well, I think, like Cory was saying, we had learned so much about how sophisticated enterprise customers were managing MongoDB in their data centers in the context of our traditional private cloud software management solution, Ops Manager. And we realized this is great. People have all kinds of advanced use cases and methodologies and governance around it, but they had to put so much effort into really making that work end to end, managing every layer of the stack, the operating system, the provisioning of infrastructure, the networking, the distributed system orchestration, the MongoDB software management, the security or governance around that, and the access controls, et cetera. And we thought, going back to actually one of the other founder of MongoDB, Dwight, he had this great saying, which was no new knobs. Keep things as simple as possible. Have really great, good defaults. Again, going back to that developer experience. So the thinking was with Atlas, let's encapsulate everything that we've learned with the best possible defaults that make it super easy to just grab what you need, declaratively deploy it, use it, and go, without needing to be an expert in all of those layers of the stack and having to manage around all that complexity. So I think that really informed just from the very beginning, keeping it crystal clear and laser focused on the user. Of course, over time, we've layered in all kinds of advanced capabilities for the enterprises, but we've still tried to make them as accessible and easy to use as possible and left them very reasonable and basically make it so that it's very difficult for people to shoot themselves in the foot, make it so that you can't turn off important defaults, et cetera. So I think that guiding light of keeping the number of knobs reduced has really been a key way that we've been thinking about Atlas since the beginning.
So I assume at this point in time, and without talking about any of our secret sauce over here at MongoDB, that we're not just using scripts to get the job done. We have some kind of pretty complex stack to get MongoDB Atlas, or at least this iteration of Atlas, working. Can one of you talk about what that kind of looks like?
So there were two categories of things that we needed to build during that 7-month development cycle. The first one was all the new stuff. We needed to be able to manage MongoDB clusters in the cloud, manage that hardware. We needed to be able to scale it up and down as customers asked us to, with no downtime. Using MongoDB was a key portion of that. And we needed to monitor the health of these clusters to be able to auto-heal as anything bad happened. The other category of development was taking all the things we already had, things Cailin mentioned earlier, like monitoring, backup, and automation that we were using in Cloud Manager, and augmenting that to fit into Atlas. So a new team was put together, which was the Atlas team, and it was in charge of the first portion of that. We needed to write this new control plane that was capable of managing all of this hardware and keeping it online at all times. And then the existing team's involvement in Atlas was really doing that augmentation. We had that monitoring and alerting platform, for example, but we needed to hide all of the monitoring and alerts that were not relevant to Atlas customers and were only relevant to people running MongoDB themselves. And I think that was a good way to see, actually, that we are taking away operational burden, right? It's here's these 20 alerts that you don't need anymore, because when those alerts go off, our system is going to do something. It's not something that you need to do.
And what did that tech stack look like? What are you working in when you're developing this functionality?
Most importantly, we ourselves store all our data in MongoDB, of course. So we have a very large MongoDB clusters ourselves, which store all of the monitoring data from Atlas and just all of the control plane data. So MongoDB is the core of our stack. all of our web services and control plane services we run in Java. And then anything that we are installing on a virtual machine that is running customer processes, like the customer's MongoDB processes, we always write that in Go. So Go, Java, and MongoDB is the core of our tech stack. I think one other thing worth mentioning about kind of the architectural principles of Atlas is that there is a very strong decoupling or very loose coupling between the control plane and the actual customer MongoDB clusters. So our control plane can go down completely and every customer's MongoDB cluster will keep running. Of course, we do our very best to keep our control plane up as well, but it is really important that our control plane can go down and a customer's business will go on just fine. Now, they wouldn't be able to log into our control plane and ask for an upgrade, for example, but whatever configuration they had running at the time that we had a problem, that configuration would just keep running.
I find the combination of Go and Java to be quite interesting. Are you able to talk about the thought process behind why those two languages were chosen over some of the alternatives?
Sure. I guess I will start with Go. We chose Go for anything that runs on a customer server back when we were building Cloud Manager, that product where we were helping customers run MongoDB themselves. And when we were helping customers run MongoDB themselves, customers were running MongoDB on a whole variety of different operating systems. And we needed to run our software on that whole variety of different operating systems. And Go happens to be a really great language for compiling into a binary that will run natively and efficiently on a whole variety of operating systems. So that was one of the things that led us to Go in the first place. I don't know, Cory, do you want to talk a little bit about other advantages of Go?
That definitely is the main one. So the very first version of the MMS monitoring agent was actually written in Python, probably because brand new product with a new person to starting a new product. That was probably the thing they were most familiar with for client-side development, right? It's usually how software projects get started. Whoever's doing the first few lines of code, pick what they like to use. So the challenge there was that not all of our customers are Python developers. They didn't have all the Python dependencies that our Python agent needed. So it was actually pretty painful for some of these customers. You could imagine even customers on Windows Shop as an example to get a Python runtime or any runtime and the dependencies available. So yeah, Go is this great blend of being able to write code at the speed that you would expect from a modern programming language like Python or Node or Ruby. But at the same time, you get that compiling down to a native binary. You don't have to bring a virtual machine or runtime.
And then on the other side, Java, it's funny, like people, I don't know, turn their noses up a little bit at Java sometimes because they think it sounds old or enterprise or boring. But it's really interesting to contrast Go and Java. So we have been running processes in Go since 2013 when Go was a relatively young language. And so we have gone along for the ride with Go, and goodness, was it ever bumpy in the beginning. We have been through so many crazy bugs with TLS handshakes in Go and just everything under the sun. We had so many really tricky problems with Go. If we contrast that to Java, we have had almost zero problems for the last 8 years. Java just does what it says it's going to do. The code is, yes, for both, but it's also very readable. You write the code, it does what you think it's going to do, and it runs perfectly every time. So I guess I'm a fan of both languages for very different reasons.
And Java being an enterprise language also has every enterprise feature or a library for enterprise feature you can imagine, which was pretty important, even in the early days with Ops Manager. Let's say we need to do an LDAP integration or a Kerberos integration or something like that. And in some more modern programming languages, those might be an afterthought, or you might be digging for a third-party library that happens to use those things, where because of the place that Java has in the enterprise environment, it just made it much easier to implement all those enterprise features. All that stuff was readily available.
And I imagine from a staffing perspective, the availability of development resources is pretty high for Java at least, right?
Well, I think it's interesting. We're We tried very hard not to be particular about what languages our candidates have experience with when we hire them. So we prefer that they have some experience in a Java-like language, but Java or C++ or C Sharp, anything that just is a compiled language in the style of Java is fine. And then we never require that anybody has Go experience. 5 years ago, that would just be silly. It would have limited our hiring pool to virtually nobody. At this point, it is more common that people come in with some Go experience, but we still, it is definitely not a requirement. We just teach people what they need to know.
Yeah. Oh, that's great. So I'd like to transition the discussion to some of the features and get an understanding of what the plan was for the initial rollout, and then what are some of the features that you thought about adding relatively early on?
The initial feature set was extremely basic compared to what it is today, but I think that we did pick like the right core pieces. We wanted to be able to launch MongoDB replica sets and sharded clusters. We wanted customers to be able to change the size of those replica sets and sharded clusters at any point, and there not being any downtime to their cluster. So those upgrades or downgrades would always happen like in a rolling fashion, and with MongoDB elections and handling any type of any replacements or upgrades and downgrades. And again, the last piece was just that if there's any cloud provider hardware failure or any other software failure, that we would be able to detect that problem and replace the node. We started with just AWS and just 4 regions in AWS, the most popular 4 regions at the time. And that was really our MVP. There wasn't a lot more to it than that. But doing that was a challenge.
Yeah, I think one of the things that was most important to Elliot, our CTO at the time, was that it was an MVP product set or product feature set, but it wasn't a toy. And for Elliot, the defining line between toy and not toy was sharded clusters. So we could not launch this unless we had support for sharded clusters. We didn't need support for LDAP authentication. We knew how we could add that later on, but sharding was a hard line. That was the most challenging thing that we included in the MVP set of features.
Yeah, I think that makes sense. That was historically one of the challenges for developers making that transition from developing just on their laptop to deploying a production application. Like, how are you going to scale this, right?
I think that's one of the greatest things about MongoDB is that, in general, not just in Atlas, is that your path to infinite scale is right in front of you. Sharding is your answer for when you need to scale, and it's very clear what you need to do when you need to scale.
I'll direct this question to Andrew, but when it comes to features like scaling or sharding and things like that, can you talk about the relationship between the engineering organization and just product for these features?
Yeah, sure. As Cailin mentioned earlier, the engineering organization here at MongoDB runs some of the largest MongoDB database clusters in the world to power so much of our backend. So we have an intimate understanding, even before we built Atlas, for how to run MongoDB at scale. Where product and our go-to-market and customer-facing teams come in is to really deeply understand what the customers are trying to do and how it is that they're planning to grow their own use cases over time. With Atlas, we always had to kind of balance an understanding for where are we with respect to what customers are comfortable to do on the platform and how they plan to grow, and make sure that we grow the possibilities of Atlas with them. So in those early days, Cailin mentioned we had sharding out of the gate. But what was interesting was we didn't yet have, for example, the ability to migrate a pre-existing sharded cluster into Atlas. So it took some time for some of those early workloads who came in to really grow to that point of sharding. And it was amazing how we did have these early customers that grew so big, so fast. But only later did we realize to really make it possible to bring the largest mission-critical database clusters that had been around for a while onto the platform, we had to build capabilities like our live migration solution that allows people to move into Atlas, flip over to the new connection string, and essentially migrate in with no downtime.
So powerful. So speaking of scaling challenges, and you mentioned it briefly, and we talked a little bit about this in episode 1 with Sahir, the challenges associated with onboarding so many customers. Cailin, maybe talk a little bit about some of those challenges that you experienced and how you overcame them.
When we launched Atlas, I think one of the most interesting scaling challenges that it wasn't immediate, but it was in our faces from the beginning, is that we were running our own infrastructure, so the control plane for Atlas, in a data center. And of course, you can expand your data center footprint, but it's slow. You need to order more racks and order more servers. So our own infrastructure was relatively non-elastic. So in parallel with launching Atlas, we also launched a project to move our own infrastructure into the cloud so that we were able to scale much more easily. Another constant scaling challenge that we share with our customers is managing our own backing MongoDB cluster. So as I said, all that backup data and all of those metrics points, we are storing a lot of data ourselves. So just like our customers, we are constantly going through the journey of splitting different types of data into different clusters, sharding our clusters, finding better ways, better schema changes that will allow us to store data more efficiently. So it's very safe to say that the cloud team has a lot of empathy for our customers whenever they hit a MongoDB rough edge or just one of those more significant steps along their journey, because we're right there with you. We are always making changes to our MongoDB deployment as well. And finally, I think one of the more interesting scaling challenges that we hit is just the limits of our cloud provider partners. We all think of the big cloud providers, AWS, GCP, and Azure, as being this, infinite pool of computing resources. But when you get to our scale, you realize that they are not. We've hit a bunch of interesting problems along the way. First of all, they all have a variety of different limits that you have to work within. So within a single AWS account, you can only have a maximum number of VPCs, for example. And there are similar constraints in Azure and GCP. So we had to figure out how to build our ever-growing deployment within their limits. So it's not like Atlas is one AWS account. It is many AWS accounts and many Azure subscriptions. And we need to figure out how to build a data model within what they provide. Second, because we are in every single AWS region and at least most Azure regions, we also hit corners of the world where we run into real physical limitations on their end. They may not have the hardware to support what our customers want to do in their smaller regions. So we have to work around that and make the experience as smooth for our customers as we can. I don't know, Cory, anything else you want to say about us hitting cloud provider limits? I feel like it is one of our more common scaling challenges.
There was a fun scaling story that happened in the first year. I think it is worth mentioning. So Atlas launched in World 2016, right? So that was in June. So in November of that year, we had 1,000 dedicated clusters on Atlas. We hit that number of 1,000 like somewhere in the middle of November. So what I worked with facilities and we organized was getting 1,000 cupcakes for the office, and we distributed them proportionally because we didn't have enough people working at MongoDB that we needed like 1,000 cupcakes in New York. So we got the proportions of office sizes and we evened out our 1,000 cupcakes. Now the scaling challenge came the next year. So 1 year later in November, we figure we'll do this again. At that point, we hit 5,000 Atlas clusters in November. So the first 6 months we have 1,000. 1 year later, we have 5,000 clusters. So scaling challenge. We had not 5x'd our employees during that time. So it did not make sense to bring 5,000 cupcakes to the office. We needed to find a different way to celebrate.
So you sharded. Awesome. One of the very mechanisms that folks are leveraging to get into MongoDB Atlas is migration. And live migration was a feature that was added, I guess, relatively early on. Andrew, you want to talk about the launch of migration?
Yeah, we talked about it a little bit before, that it was just so important for all the folks with real MongoDB database workloads to be able to come over with no downtime. And I think that's been the foundation for so much of the growth over time. Of course, the bigger Atlas becomes, the more we see really born in Atlas workloads starting to dominate. But there's still those big self-managed databases out there, and every day we see so many of them coming into Atlas through that migration service. But there's another form of scale that was important that we released at, I think, roughly the same time, which was not so much about the big pre-established users of MongoDB database clusters who needed to come in with no downtime, but all the long tail developers who wanted to get started on the platform. So that's where it was really important for us to build this free tier, a place where you could come in, get a free forever sandbox and just try new ideas and get that instant gratification experience with MongoDB. And the architecture behind the scenes on that one's really interesting.
That is also a very interesting scaling challenge, right? Because I was just mentioning we had 1,000 clusters after 6 months. We have 5,000 after a year. In terms of our current monitoring and backup infrastructure, that wasn't that significant because we had all of those cloud manager customers that we had built up for the 4 or 5 years prior to that. Where those systems really started to get exercised was when we added that free tier. Because we now had thousands, or at this point, tens of thousands of signups and new users to that per week, as opposed to new dedicated clusters, which might be in the dozens or hundreds per week.
Yeah, and I can imagine from a cost perspective, like we're deploying infrastructure resources on behalf of the customer. And when you talk about free tier, obviously that could be quite expensive for us offering a free service. What does the architecture look like? Obviously, we're going to leverage virtual instances, so the cost will be reduced, but still it's a non-zero cost to us. Is that correct?
Yeah, that heavily drove the architecture, deciding on what the cost model would be, because we knew that we needed to be able to pack lots and lots of free customers onto those virtual machines so that whatever, in the end, it's a business, right? So whatever rate of those customers were going to become paid customers over time, the cost model for the free tier had to make sense and had to support that. So there were really 3 architectures that we looked at. One was, can we make MongoDB like a multi-tenant database? Just part like large MongoDB server projects, and it just understand multi-tenancy in a way it doesn't today. Another thing we looked at was, can we pack lots and lots of MongoDB processes on one VM? Can we just run 2,000 MongoDBs? And the last one was just can we build some kind of proxy that sits in front of MongoDB and makes it look like a multi-tenant service, even though that's not actually what it is under the hood. The first one, being able to do that MongoDB server project, would have turned into a multi-year thing. MongoDB itself knew nothing about multi-tenancy. So that was just ruled out from a timeline perspective. The second one was tough just because MongoDB was never architected to run in a tiny amount of RAM. So it would have also ran into this same server problem, right? If we wanted to run 1,000 MongoDBs on a server with 16 or 32 gigs of RAM, you could do the math. There would be a very small amount of RAM MongoDB would be allowed to use. And all the developers of MongoDB would have to think about that permanently, right? For the rest of their careers at MongoDB, anytime I allocate memory, it has to stay in the megabytes. It can't go any beyond that. So we arrived on that third solution, that the cloud team actually built a proxy service that sits in front of a MongoDB. And to customers connecting to that, it makes it look like they have their very own MongoDB instance, but it's actually sharing MongoDB instances on the back end and using some clever namespacing tricks to make it look like it's just their own.
Fantastic. And what a clever solution. And I can imagine, there are several database as a service offerings out there on the internet today. This would appear to be fairly massive competitive differentiators. Is that correct?
Absolutely. With the size of this community and making it so easy every day for so many thousands of developers to experience MongoDB for the first time, it's just such a huge part of what makes MongoDB have so much, longevity. It's in a very unique place in the market where you're going through this multi-decade shift away from this table-based way of working with data that we all know and love since the 1970s. But now we're going to this new, more developer-centered model. And MongoDB has to invest in just making it so easy to get into this community. And the free tier is a huge part of that. MongoDB University is a huge part of that. And of course, all of the user groups that exist all over the world.
I love the focus on the free tier and migration and lowering the bar for entry for customers and developers to use MongoDB. But I know that we have many customers in the large-scale enterprise space. So maybe Cory, talk a little bit about the focus that we've placed on developing features in the enterprise space.
Sure. So early on, as soon as the growing Atlas team became large enough that it couldn't just be a single development team anymore, we needed to split it into 2. And the path we took was forming an Atlas community team and an Atlas enterprise team. And that way we can separate the concerns of those 2 customers. As Andrew mentioned, we have a lot of smaller companies, a lot of startups. They're interested in very cloud-specific features and new things coming out there. But then we also have a lot of traditional enterprise customers where their main concern when they switch to Atlas is, how do I still meet all of my security compliances and regulations and things like that? So that's what that Atlas enterprise team early on did. They built our LDAP authentication features, our MongoDB auditing features, being able to connect to MongoDB with X509 certificates, encryption at rest, bringing your own encryption keys. So all those things that we needed to bring in those large enterprise customers.
Yeah, I think there's been two themes for enterprise development in Atlas. One of them was exposing the features in MongoDB itself that have been there for years. So as Cory said, things like LDAP authentication. So that was available to on-prem customers of MongoDB for many years, and we just needed to expose it in Atlas. And then the second is integrating with the enterprise security features of the cloud providers themselves. And that tends to be all of the private networking features. So for example, integrating with VPC peering or private link for AWS and the equivalent on the other cloud providers. Another one of my favorite things about our enterprise feature development stream is how obvious it is, I guess. Our enterprise customers are always very unified in their requests for precisely what they want. So it's very clear what we need to do. It's just a matter of ordering it so we can make the greatest number of customers happy fastest.
You have an example of that, like them being super clear in their request?
Well, I mean, Atlas had been live for about 30 seconds before everybody was like, we need VPC peering on AWS. We were like, okay, kick off that stream. And then, they want the equivalent on GCP and the equivalent on Azure. And then they wanted beyond just Atlas, like federated authentication for the control plane. So the ability to hook up logging into cloud.mongodb.com to their Okta instance, single sign-on, that kind of thing. Everybody wants the same stuff, which is great.
Yeah. VPC peering was actually a great example because we hadn't talked about it at all in that 7 months development, right? It hadn't really come up in any of our lists, I think. And then what happened is we released Atlas, and I was hanging out in the MongoDB World booth, to answer questions for people, and people kept bringing it up. And Andrew kept saying people kept bringing it up. And it's literally the first large feature we built. I think we started working on it in August, even though the product was released in June. It just skipped the list because it was immediately obvious that everyone needed it.
And there's another aspect of all this. We're talking features and functionality, which are vital, to Cailin's point, to integrate in and be a governable part of one's broader cloud estate. But then there's also, as we evolved to become a cloud company, we had to build all these new muscles and change our DNA. And I think a lot of our listeners today may be also people building SaaS companies. And there's this whole journey you go through where you learn how to make sure that you're doing things right. And that's where these third-party security and compliance certificates come in. You go through this, it's just each step of the journey. You go through a SOC 2 Type 1, where you're bringing in experts to validate how you're governing yourself. Then you do SOC 2 Type 2, you do ISO 27001, PCI DSS, HIPAA for EPHI data. And each kind of step of the way, you're getting a little bit more confident that you're validating that your governance, your controls, your best practices are there end to end. And you're helping your customers to understand that you're doing things right. And that all of that was important as we kept going along this journey.
Fantastic. So this is a great journey, and this is a fantastic podcast episode. Is there any kind of last minute words of wisdom or anything that you feel like we missed that you really want to get into the minds of the audience as we begin to wrap?
Oh, goodness. Nothing is really coming to mind. Of course, there are a million details that we didn't have time to talk about, but I think we've done a good job of doing a broad brush of Atlas, from its history through a little bit about the team, its feature set.
Hey, if I could put you on the spot, what's your favorite feature that was added to MongoDB Atlas?
Oh, my favorite feature, this is such a funny one. I really love the time-limited IP access list and MongoDB users. So I can temporarily add an IP to the access list, or I can create a temporary user, which means if I'm at a coffee shop and I need to access a cluster, I can put the IP of the coffee shop on the list and just for 6 hours and have faith that even if I space out about it, it will be removed.
I love that feature, and I use it all the time as well. I'm curious about how that came to be. Where did that idea come from?
We saw this problem so frequently, especially in the financial services space. Our banking customers, they had to build all this governance around temporary privilege escalations of users and such. And they just directly told us, if you could do this, it would be a real differentiator for you in a true managed service environment. And we're so customer-centered, we love hearing those suggestions and incorporating them into the roadmap.
And that's the beautiful thing about MVP. You deploy something, you listen to the early adopters, and then you you get busy with their requests. I was working as a sales engineer at the time, and I didn't hear that specific request, but I did hear VPC all of the time from the customers I was talking to. So any other favorite features that anybody wants to mention?
This one's pretty new. It was in last version of MongoDB, which meant it came to Atlas last summer. But I'm a really big fan of the IAM authentication that we added, that you could authenticate to your Atlas clusters using AWS IAM authentication. I just think it makes it feel now like your Atlas clusters are an extension of the rest of your AWS infrastructure and not just something on the side that you have to think about integrating.
That's a great one for sure. All right. Well, I want to thank all three of you for your time. It's been a great discussion. We've learned so much. And again, a reminder to the audience, this is episode 2 of a 4-part series. We're going to get mobile next. We're going to talk to Alexander Stigsen about Realm and how that was added to the platform. Once again, thanks everybody.
Thank you.
Thanks for having us.
Thanks so much for listening. Be sure to subscribe and provide a comment and a rating. If you want to learn more about MongoDB Atlas, visit mongodb.com/Atlas today to sign up for your free account to get started right away. Also, be sure to tune in to our biggest user conference of the year. We're streaming live on July 13th and 14th, 2021. Registration is open for MongoDB.live. This is a free virtual streaming event that will feature a solid lineup of cutting-edge keynotes, dozens of breakout sessions, live Ask Me Anything panels, brain break activities, and so much more. Head on over to mongodb.com/live to register and to get updates for what's in store in July.